So in this video we're going to talk about solving absolute value equations, but before we do some examples I want to just talk to you a little bit about what is an absolute value and what it looks like. So first of all, the true definition of an absolute value is it's the distance a number is from zero. So for example, if I ask you what the absolute value of the number 3 is, the answer would be 3, because if you think about a number line and here's 0 and here's 3, you're looking at 3 units from 0. But on the reverse side of that, if I ask you what the absolute value of negative 3 is, this is also going to be positive 3, because again, thinking of a number line, here's 0, and if I go to negative 3, it's also 3 units from 0. When we talk about distance or units from 0 in mathematics, it's always going to be in the term of a positive. So one of the things you might have also heard about absolute value is absolute value makes everybody positive. And that is completely true. It does make every number positive because we're looking at the distance, and in mathematics we always talk about distance in terms of a positive value. So what we're going to be looking at is not knowing the value of the absolute value, but knowing what it is equal to. So for example, if I had asked you what the absolute value of x equal to 5 would be, I have to think in two directions. So again, thinking of a number line, if here's 0, one option I could do is if I went 5 units to the right, I would end up at a positive 5. So x could equal 5, because if I did the absolute value of positive 5, I would get 5. But remember, my number line goes in two directions. I could go to the right, but I could also, from 0, go to the left 5 units, because again, distance doesn't have a sign, it's just a direction. So here I would end up at negative 5, so x could equal a negative 5. And I actually end up getting two distinct answers, a negative answer, or a negative side, and a positive side. And that's going to be something that we're going to take into account when we do some example problems here in just a minute. But I also want to look at what happens if I have the absolute value of x is equal to 0. Well, remember that this is asking us what number is 0 units from 0. Well, again, think of a number line. If I'm sitting here at 0, the only number that can be 0 units from 0 is 0 itself, so x equals 0. And you only end up with one solution. And another example I want to talk about again before we look at some problems from Hawks would be the absolute value of x is equal to negative 5. Now, remember what I told you earlier. We've said it a couple times, but absolute value makes everybody positive, or the distance from 0 is always in terms of a positive. So in this particular case, we cannot have the absolute value equal to a negative. So we would actually say that this particular problem has no solution. Okay. So then, just for general, so you can kind of see when we're working these problems how they work out. In general, if you have the absolute value of x equal to a positive number, then you are going to have two answers. Sometimes they may be like that one example we just did where we had x equal to negative 5 and positive 5. Sometimes they're going to be two different answers, and we'll show problems like that as we go through. If we have the absolute value equal to 0, we're only going to have one distinct answer. And then if we have the absolute value of x equal to a negative number, in this particular instance we would have no solution, or no answers. Okay, and let's do one. So for our first example, we're going to solve the absolute value 3y plus 5. So the absolute value of 3y plus 5 minus 2 is equal to 0. And as we do this, let's go ahead and write out the steps that we need to take in order to solve this. So the first thing we need to do is we need to get the equation in what we call standard form. Okay. That's just code for we want to isolate the absolute value. Okay, so basically we want to make sure that the absolute value is all by itself on one side of the equation and our constant is on the other side of the equation. And typically what that means is we're going to have our absolute value over on the left and our constant on the right. Although we can reverse it, it doesn't really matter. Now that means that this negative 2, which is outside of my absolute value, it's subtracted onto it, needs to be moved over here onto the other side with the 0. Well, just like we did back when we were solving equations, we're going to move it using the opposite. So we're going to add 2 to both sides. These 2's would cancel each other out, so we would have the absolute value of 3y plus 5 is equal to 2. And this statement right here is the standard form with the absolute values included as part of your answer. So if somebody asks you to state the standard form, they're looking for this particular answer right here. Now our second step is where we actually start getting to the point where we can solve. So the next thing we need to do is we need to write the 2 possible equations. Now remember what we talked about when we did that absolute value of x is equal to 5. We said it could equal positive 5 or negative 5 because we could either have the negative side of our problem or the positive side of our problem. These are exactly the same way. We just have something a little bit more than just an x in our absolute value. So we need to write our negative side of the equation and we need to write the positive side of the equation. Now the biggest thing you have to remember when you write these equations is you are not changing anything about what is in this absolute value. The only thing we're changing is the 2. So this would become 3y plus 5 is equal to a negative 2. And for our positive it would be 3y plus 5 is equal to 2. Notice that when we made the negative and positive equations, we actually dropped those absolute values because you're acknowledging the definition of an absolute value in that it's the distance a number is from 0. So we're looking at if we go to the left 2, that gets us at negative 2. If we go to the right 2, that gets us at positive 2. So we actually have 2 separate equations. So for our third step, we are going to solve each equation. And we're going to do this just like we did way back in solving linear equations. We're going to start with this 3y plus 5. We're going to subtract 5 from both sides. That gives us 3y equals negative 7. We're then going to divide by 3 on both sides. So y equals negative 7/3. And there is one answer for our problem. Now we're going to do the same thing over here to our positive equation. We're going to subtract 5 from both sides. So this time we get 3y equals negative 3. We're going to divide both sides by 3. And we get y equal to negative 1. So there's our second answer. Because remember what we talked about, we had those 3 general things, and since my absolute value is equal to a positive number, once I got it into standard form, I know that I'm going to get 2 distinct answers out of my solution. Now I actually want to write this in what we call solution set. And what that looks like is we're going to do a curly brace. We're going to use our smaller number first, which is almost typically always going to be associated with our negative side. So that's going to be negative 7 over 3, comma, and then we'll use our next number, which is negative 1, and a curly brace. So the last step you have to do is graph the answers. And this is actually not too difficult to do. We're just going to put dots on our graph for where these two answers are. Okay, so here is 0, here's negative 1, here's negative 2, and here is negative 3. Negative 1 is obviously right here, so we're just going to place a dot right at negative 1. Now, negative 7/3 is a little harder to see on this because it is a fraction, but negative 7/3 is the same thing as negative 2.333. And for what we're going to do, we're going to estimate, but when you do your homework on the computer, it should be marked on there as negative 7/3 for you, so you shouldn't have to estimate anything. But negative 7/3 is going to be about right here, and we're going to put a dot there as well.